Next, I'm going to talk about something called couple. Okay, couple is something that's very, very common in statics analysis. Now, imagine you're trying to open like a vault door, okay? And I don't know when or how often you'll be doing that, but or let's say you're driving, right? So let's say it's a steering wheel or something, okay? So you're doing this, okay? So you apply this force right here at this point, and then apply the other force from the other hand at the opposite point, okay? So you're doing this, okay? So let's say you're trying to turn, right? Trying to turn clockwise. So it's like this picture right here, okay, or this picture, right? So you apply a certain force going to the right, and apply the other force going to the left, okay? So let's say you apply the same forces here and here, okay, which is this picture right here. Now, this force and this force, okay, now this force can be thought of as F. The other force has the exact same magnitude, it's negative F, okay, since it's the opposite direction. These two forces are completely opposite direction, okay? So if you do a sum of forces, okay, so this system right here, so this system has only two forces. So sum of forces in, let's say, this direction, whatever this direction is, okay, equal to 0, right? Because this is cancelled out by this. So sum of forces for this system of forces is 0. So linearly, they don't have any end result, okay? To want to make an object try to move, okay, or shift linearly, because sum of forces equals 0. However, because of the fact that these two forces are separated by a distance, the distance is d, okay, they will tend to create a moment or some kind of rotational effect, okay, a tendency to want to make an object rotate, but they won't make this object try to shift, okay, because sum of forces equals 0. However, they will have a tendency to try to make this object rotate, which is exactly moment. Okay, so there will be a resulting moment, and this pair of forces is exactly coupled. Okay, so couple is a pair of forces. Okay, so it consists of two forces of equal magnitude, parallel to each other, but they're non-collinear, which means that they are not along the same line. Okay, so they have to be separated by a distance d. Okay, a d is the shortest distance between these two forces. Their perpendicular distance. Okay, perpendicular distance. So let's come up with the moment, the magnitude, and the direction of the moment created by this couple now. Well, let's look at this picture right here. Okay, so let's imagine you're opening a vault door. Okay, again, it's like this, right? So you apply a force at this point going to the right, the other force going at the bottom going to the left, right? Exact same amount of force. Okay, so the tendency to want to make this object rotate is like this. Okay, but it's not moving. It's not actually rotating. All right, so the whole thing is in static conditions. It's not moving. But the tendency, if I apply this force and this force, right, the tendency is to want to make this object rotate this way. Okay? So, here's the picture. If I call this force going to the right as positive F vector, and the other force is negative F vector, equal magnitude, right, opposite direction, but separated by a distance. Okay? Now, if I define this point of rotation as point O, okay, this vault, right, handle, and I can define my displacement vector RA, okay, measured from point O to point A. Similarly, point O to point B. But I can also define this position vector from point B to point A, okay, which is this vector right here going up. And that's exactly position of A relative to B, which is R A slash B. Okay, so the position of A relative to B, and by definition is exactly RA minus RB. Okay, so RA minus RB. Okay, so we just call it R. Okay, so it's called this big vector, this position vector, R. Okay, let's do this sum of moment about point O considering these two forces. Okay, so there are two forces. So now we have two terms. Sum the total moment, okay, about point O. First of all, due to this force is the moment about point O, comma, due to this force, the first force, plus the second force, negative F, okay, the bottom force. Okay, so for this first force, it's simply just R cross F. It's RA cross F, right, because it's about this point right here, point O. Similarly, for the second force, moment about point O is RB cross F, or cross minus F. Okay. Do some math operations here. So this right here, just take the negative sign out. Okay. And then next, combine these two. Okay. Property of cross product, okay, is distributive. Right. So RA minus RB cross F. But look at this. This is exactly R. Okay, which is really RA relative to B. Okay, RA slash B. So I'm just going to call it R. So it's R cross F. Right? So this big R crosses with an F vector. Okay? But look at this right here. This point O. Let's take a moment about this point O. This point O is arbitrary. I could also do the same analysis for some other point, point B, okay, or point Q, any way you like. Okay? Then you can define same thing, RA going from point B to A, RB this way, okay, and then RA slash B, or just R, it's still the same. It's right here. It's always going from B to A. Okay? So regardless of where this point is, what this point is, right? It doesn't have to be this point O, right? It's arbitrary point. Say for point B. So moment about point B still exactly the same as R cross F as before. So therefore, the moment created by this couple right here is exactly R cross F. It's just R cross F. As far as which point is the moment about, well, it's meaningless to talk about a point now when we talk about couple. Okay, because this point or this point or this point is arbitrary. Right? We don't care really about what this point is. So moment of a couple is called free moment. Okay, because it's not constrained to a point, right? So it's defined by R, is measured from one point to the other point, okay, where these forces are applied. Cross F, okay, so an F vector, okay, that's it. As for the sign, okay, or the direction of this F, well, or the M couple, you just look at the direction of the F. Look, it's right here. F force on top going this way. F4 at the bottom going to the left. So, again, this has the effect of wanting to make this vault or steering wheel, whatever it is, to want to rotate clockwise. Okay? So, using right-hand rule, clockwise rotation, your thumb is pointing into the board, into the paper. So that would be the direction of the M couple. Okay? And then the magnitude of the moment created by couple is simply force. Okay, whatever that is, the magnitude. Just keep in mind they have the same magnitude. Okay, so it's the force times the distance between them, the perpendicular distance between them. Okay, let's call it d. Okay, so this distance, call it d. Okay, so let's say this is 100 Newton, right? So this is 100 Newton, right? Going to the left, right? So let's say this is my x-axis. So this is my I, right? So this is 100 negative I. Okay? So the moment created by this couple right here, let's say this is let's say 2 meters. Okay? So moment created by this couple in this picture is exactly equal to 100 Newton times 2 meters, so 200 Newton meters. That's all.